Hello everybody, thank you for checking out my Unit 4 Day 2 video, which I'm going to call Advanced Volume or Enhanced Volume, or just simply solving more problems that involve volume. So to start down here on the back of my flipbook, I have these. What happens to the volume of a sphere if the radius is doubled? So what you really want to do is explore the formula and what exactly happens to the radius. The formula for volume of a sphere is 4/3 pi r to the third. So note the main thing that's happening to radius and the first thing that's happening to radius is it's cubed. Now if I double it, that means I'm going to times it by 2. But that times 2 ultimately raises to the third power. 2 times 2 times 2 and becomes 8. So the volume is really going to multiply by 8. And it might not seem exactly correct. It seems a little bit too much. Simple-minded thinking would probably say that, okay, if I double the radius, then the volume is just going to double. But most of us understand that it's not always going to be that straightforward. There's supposed to be something at least a little bit complicated about it. So I took the formula for volume and I went ahead and pre-programmed it in over here on Desmos. And let's say you start with a real simple volume like 1. If you double it, that would be 2. And notice what happened. We went all the way from 4.1 all the way to 33.5. And that is times 8. By the way, I labeled them A and B. So that way on the next line, I could say, what's B divided by A? And it'll do the exact B divided by A and tell us that, hey, it is times 8. What about if I triple the volume? What about if I triple the radius? Then I would go from 1 to 3. And now I went all the way from 4 to 113, which apparently is 27. Let's go back to the formula and see if that makes sense. So if I'm tripling the radius, so again, the formula is 4/3 pi to the third, pi r to the third. Tripling the radius and then raising it to the third power, that triple would go to the third power and be 3 times 3 times 3, which is a multiple of 27. So might not seem like it, but just simply tripling the radius would multiply the volume by 27. So is it the same in other shapes like cone? Well, remember cone is 1/3 capital BH, shaped like a triangle, so it gets 1/3. The base is a circle, so this time it's pi r squared. So if I double the radius, that times 2 only gets squared now, and 2 squared is just 4. So doubling the radius would only multiply the volume by 4. And finally, what if I tripled the radius of a cone? Do you know what the volume would multiply by? So hopefully maybe you paused it and thought about it for a second, but by the time I triple my radius, remember in a cone, the radius is squared according to the formula. So tripling and ultimately squaring it, tripling and squaring it would be 3 times 3. The volume would multiply by 9. So that's one form of advanced volume, quote unquote. We'll do a few problems where in many of the problems, we're going to use our volume setup, but now instead of calculating volume, we're going to work backwards and maybe find the radius or find the height at times. So I'm still going to use the same formula. Cylinders are shaped kind of rectangular, just capital BH. The base is a circle, pi r squared. And now that I got my formula set up, I'm going to plug in what I know. I know that the volume is 628. I know that the height is 2. All I got to do is just because it looks like a strange equation, it's definitely not. Still follows the same old rules that any other equation would. I'm still trying to get the variable, or in this case by itself. I get rid of times 2 by dividing by 2. I also can get rid of times pi, because pi is multiplying with r as well. I can divide by pi, and I can do them at the same time. The pi's will cancel, the 2's will cancel, and I'm left with r squared equals 100. We all know how to get rid of a square. Square roots and the square root of 100 is just 10, and our radius is just 10. Another example, if I do a cone, this is number 13 in your flipbook, whereas I just did number 11. Cones, remember being shaped like triangles, they're going to have that 1/3, and the base is still a circle, so 1/3 pi r squared h. Let's plug in what I know. I know the volume is 2512. I know that the radius is 20. Let's note again. Another equation might look complicated. Just follow your equation rules. I got to get the variable by itself. The variable is h. All I need to do is get rid of all this other stuff with h. I got to get rid of the 1/3. It's furthest away. It's multiplying with h. All this stuff is multiplying together. How do I get rid of 1/3? Well, you can times by 3, or you can divide by 1/3. How do I get rid of times pi? I can divide by pi. I know 20 squared is really 400. It's timesing. I'm going to divide to get rid of it. Don't think because there's an exponent that you got to square or something. You can simplify that exponent. 20 to the second power is 400. But regardless, it's multiplying with h. We always do the opposite to get rid of things. What I do to one side, I got to do to the other. So I'm going to divide 2512 by 1/3 times pi times 20 squared. Oh, I already have it on this line right here, 5.99. Of course, remember, when you're dealing with pi, pi is never going to really work out perfectly. My height is 6. Said 5.99 must be a height of 6. One more, let's do a sphere. So I've so far done a cylinder, a cone, and now a sphere. These ones are really good because in this type of problem, you're looking to find stuff like radii or height. So the volume of the sphere, this one is like 21 and 22 in your flipbook, but there wasn't a whole lot of practice on them, so I didn't want to do exactly one of the ones out of the flipbook. Volume of the sphere is 523.6. So again, I'm going to write the formula first. 4/3 pi r to the third. Volume load is the number 3. If the volume is 523.6, I'm going to put that in the volume spot. And finally, I'm not told anything else. How many variables do I got? I just got one, and it's r, so I can proceed to solve. What's furthest away from r? That 4/3. How do I get rid of it? You can multiply by the reciprocal, or you can divide. How am I going to get rid of pi? Well, pi is also multiplying with r, so I'm going to divide by it. But don't get too caught up in the fact that how do I get rid of this 3? I don't divide by 3, so I'm not going to put that cube down here. I know I did something similar last time. I was multiplying by like a number to a power. I divided by that. 4/3 will cancel, pi's will cancel. I'm left with r to the third power equals whatever 523.6 divided by 4 pi is. So let's check this out. Hey, I got it up here. You get 125 equals r to the third. So finally, remember, how do you get rid of a cube? Just like we got rid of a square a little while ago, you get rid of a cube by cube rooting both sides. So I'm going to end up, when I cube root, the cube will cancel. The cube root of 125, make sure you know how to go on Desmos and get the cube root button. You can't use the square root button. You can't just put a 3 in front of it. You hit functions, you go all the way to the bottom, and you pull this button that lets you put any root that you want to. And once you press that button, then you can type in the 3 for a cube that you want. But anyways, again, I already have it typed in down here. Wait. Oh, it's not that number, so good. I do get to type it in. So 3 for cube root and 125. And that's 5. And we know from factoring cubes a few weeks ago that 5 times 5 times 5 is 125. Special note though, the radius is 5. I've noticed that a lot of high stakes tests will maybe make you do all that work and then they'll ask you for diameter instead. The diameter, of course, would be 10, or even circumference, which we'll talk about a lot in circles unit. Circumference is always 2 times pi times radius. So 2 times pi times 5, or 10 pi, or about 31. Don't worry about circumference in my current unit. Anyways, that's that for this video on advanced or enhanced volume. Thanks so much for watching.